Alright, so we got a new project, a small little drilling, reaming job to do on the mill. Two channels, pretty much identical except for one has threaded holes and the other one does not. Two sets of drawings, looks like Google SketchUp or some other type of cheaper software. Here's the two pieces of channels here, aluminum. Fairly clean. We'll do some layout, and then what we'll do is we'll throw her up on the old Bridgeport there, and then we'll get these holes accurately placed within the channel. Okay, like I said, they were pretty sketchy drawings, maybe Google Sketch, so here's a close-up of the drawing I was given. And it's okay if you're going off a CNC off a computer, right? But we just got a regular old Bridgeport here, so we have to kind of go off 1x and 1y coordinate. So no big deal. We just take some time and we map out our sequences and holes that we're going to go and lay out, center drill or center mark first. That way that there's no errors. And then we might do a little blue layout just to make sure that our coordinates are looking pretty good. Okay, so I'm just noticing why the guy contacted me to do this. I don't know if you can see this too well. He's already started to try and lay out these holes, and apparently it was a little too much layout or too hard for him to decipher what he wanted done there off the sketch that maybe possibly somebody else had sent him, but he definitely sent it to me. And it was poor. Okay, so we're going to set it up on our Bridgeport, and we're going to start seeing how it's looking. Open up the vise, put it in there. Probably we're going to be putting some screw jacks under the end to keep the pressure off. And we're drilling on the outside holes. None of this is overly critical. He just wants them drilled just for clearance. But they still have to be close. So I think the way we're going to set it up here should be close enough. So I get it in there, I'll check the travel of the mill to make sure that we've got enough clearance to grab both ends. Give it a shot of lube, let it work in as it travels back and forth. Maybe a little further than I'd like it to be, but we'll check the travel out in the other direction. Give another shot of lube. We're pretty much maxing out my table, so we'll have to just have to tweak that, make sure we're good to go. Okay, so we're almost set up here. I got it so that my mill can reach each of my furthest set of coordinates. I'm going to set up these jack stands now. I might go with the double vise setup if it was if accuracy was a little more of an issue, but it's not, so this will be fine. The lock nut down there. Again, like it's just to keep the pressure from drilling, to keep the aluminum channel from deflecting as we continue with our order of operations, placing these holes. Okay, so I got my my centers lined up, my screw jacks on the ends. I can reach everything, I believe, from this position. So I'm going to go and center drill them. Okay, so there's all the center ones drilled on this side. Problem with the mill, sometimes you split hairs. Just the lotto feed on a long travel. Okay. Okay, we're back. Okay, here's all the center drills all marked out. I stopped for a minute there, something wasn't adding up. I double checked everything with the caliper. Everything looks good. So now we're going to change out the bit and we'll commence drilling different sized holes. Okay, so now I'm going to put in a 3/8 drill bit. It's aluminum. I don't think I'm going to do a pilot. Just going to try and see if we can make it through there. Alright. Okay, we're going to be drilling our 3/8 holes, which is 0.375. Just find our locations again. I found that trusting our DRO for the most part is the way to go. Okay, those are those holes. Now we're going to switch out to our tab size for a 3/8 16 National coarse thread, which is going to be a 5/16 drill bit. We'll switch that out. Okay, it's looking good. Here we go. Okay, here we go. Okay, now I got 2 3/4 holes to drill on the outsides and 1.250 inch and a quarter to drill in the middle. I'm going to set up for using a hole saw and do a little review, I suppose. That's what we do. We're going to do a regular high-speed steel-toothed Mastercraft bimetal. Then we're going to use a Mastercraft carbide tipped for the 3/4. And we're going to see how they perform in the aluminum. I'm expecting they should perform pretty nice. Okay, so we'll start off with the carbide inserts there. I'll try and zoom you guys in since I'm not going to be moving around too much. We'll see how that works. Okay, see how that goes. You guys all set up there pretty good? Well, we'll see. Those two there pretty good. I might use a little bit of aluminum fluid or WD-40 next time. So running it hard like that without fluid looks like it just a little bit of galling to the teeth. It should come right off. Okay, so we're set up for the other 3/4 cut. Now I'll use a little WD-40 and see if that makes a difference. And as we all assumed, of course it made a great difference in how clean the cut went through, how the chips came off. So I'll center it out and change to my 1.25 inch bit, and we'll check that how that high-speed steel cuts. Okay, we're going with 1.25 inch one. For all the purpose intended, I think it turned out pretty good. Once I get it out, or I might end up tapping it in there, or we'll see. So because we can, what we're going to do is we're going to tap it on the mill, just to keep the integrity of the hole as close as possible to the 90 degrees in parallel as intended there. The mill, just keep a little bit of pressure on that. Keep it lined up. I started these probably by themselves, but like I said, since we got the mill set up, we will use the coordinates in the mill to get a nice straight hole. Got the second last hole here. Okay, that's this one operation complete. Alright, so all I have to do now, rinse and repeat, except I don't have to do the 6 tapped holes on the next one.